All right, let's take a look at number 11. So an object falls at 9.8 meters per second. What does this mean? Well, it means a couple things. It means we're gaining speed. We are gaining. All right, number 11. So an object falls at 9.8 meters per second, and it says this means. Well, let me try to write out what it means first and see if it matches one of my answers. So I know it means, in one sense, it gains speed at 9.8 meters per second each second. And after 1 second, its speed is, I'll say, it means that, I just can't read this. All right. Continuing on with the multiple choice, we're going to take a look at number 11. So it says an object falls at 9.8 meters per second squared, and it wants to know what this means. So let me write out what I think it means. Number 1, we gain speed at 9.8 meters per second each second. That's one thing. The second thing is, at 1 second, v is 9.8 meters per second. So let's see. An object falls at 9.8 meters per second. This means it falls 9.8 meters only in the first second. False. Its speed may be 9.8 meters per second at 1 second, but it needs to accelerate up to that. So it's actually going to fall less than that. It actually falls 4.9 meters. And I want to challenge you to see if you can figure that out in your head, though you could write it down. But see if you can get that memorized. It actually gains speed at a rate of 9.8 meters per second, which we just wrote in number 2. It does not fall 9.8 meters, which is really funny because this and this are kind of similar. It has a velocity of 9.8 meters per second. Yeah, it does after 1 second, and we don't need to know the mass to determine anything else. Now for number 12. We have a certain nonlinear spring. It requires this force to stretch it, and we want to know the change in potential energy when the spring is stretched from 2 meters from its equilibrium point. So let's calculate the work, and then we'll take the negative of that to get the potential energy. So 40x minus 6x squared dx from 0 to 2. And that's going to be 40x squared over 2 minus 6x cubed over 3 from 0 to 2. Continuing on here, that's going to be 20x squared minus 2x cubed from 0 to 2. So I'm going to get 20 times 4 minus 2, and x cubed is 8. And so I'm going to get 80 minus 16, and that's going to give me 64 joules. So apparently they're just looking for the magnitude, so I'm getting 64 joules as far as the change in potential energy goes. Excellent. Now, when a block slides a certain distance down an incline, the work done by gravity is 300 joules. What is the work done by gravity if the block slides up the same distance? So positive joules as it goes down the incline, and then the gravity force does negative 300 joules of work to slow it down, and then that work is stored as gravitational potential energy, as we discussed in class. Number 14, a ball is thrown upwards at a height of 10 meters. It has a potential energy of 50 joules and is moving upward with a kinetic energy equal to 50 joules. And we want to know the maximum height reached by the ball. So let's be clear. We have mgh plus ke equals 50 joules plus 50 joules to start with. And then we have a final height, mgh2, equal to, well, since we're at the maximum height, that's going to be 100 joules worth of energy. So let's see if we can figure this out. I have m times g times 10 gives me 50 joules. And so here, if I want to get 100 joules worth of energy just by increasing the height, I'm going to need to double my height. So this is going to be 20 joules worth of height. There are plenty of ways to solve this problem. But what I'm doing here is I'm using conservation of energy. So this is at the beginning. And at the end, since I'm at the maximum height, there's no more kinetic energy. I need you to sit with that and really see if you can reconstruct my reasoning. So I went through that kind of quickly. So it's very tempting to sit with this and say, I did not immediately understand Mr. Abdullah's explanation. So let me watch the video 3 or 4 times and hope that's going to clarify it. I'm going to suggest something a little stronger. I want you to try to solve the problem using your own creative thinking and see if you can use my answer merely as a guide, because constructing that mental connection yourself is really going to be the work of learning AP Physics. So I want to challenge you to do that. And in fact, I'm going to push back a little bit if you have questions about number 14 and challenge you to kind of do that on your own. So number 15. A specially designed spring is stretched from equilibrium to the distances given. F is measured and recorded. What is the potential energy of the spring when it is stretched 3 meters from equilibrium? So we've got the X and the force, and there's some kind of relationship here. And this is one of those things where they're kind of expecting you to notice a trend, a relationship between these numbers. So if I am at 0, my force is 0. If I'm at 1, my force is at 1. When I stretch to 2, my force becomes 8. When I stretch 3, my force becomes 27. And 4, my force goes to 64. What they are expecting you to immediately be able to see with these numbers is 4 cubed is 64. 3 cubed is 27, 2 cubed is 8, and they expect you to be able to look at this table and actually on your own be able to come up with this formula as the general trend of F versus X. How did I come up with this? I noticed a pattern between the numbers. And there's no, how do you teach me to notice that pattern? It's just one of those things that you do enough math, you're expected to be able to hold your own on that. I wish there were a nicer way to say it. It's rather cruel of the AP to do it that way. And these are kind of things that we expect you to sort of pick up in math class. I think it's a little tough to kind of just say that, but that's really how it is. So let's integrate to get the work. So we have work is x cubed dx from 0 to 3. And so that's going to be x to the 4th over 4 from 0 to 3. And so that's going to be 81 over 4 joules. So I'm getting choice C. It seems in the AP that I'm really not worrying about sign very much. So that's numbers 10 through 15. And then we'll finish up the multiple choice in the next video.